Hello everyone, how are you doing today? My name is Guido and today I will be telling you about MDX programming basics. And the main goal of today's webinar is to learn MDX programming basics so you can write basic and advanced MDX functions. We will do another webinar where we will be covering the most commonly used functions in MDX. So this could be like an introduction for how to use them. Today, this is the plan for today. We will cover data types, case statements, structure of MDX functions, debugging, comments, making groups, and formatting. Most of the time we will spend on data types because these are the basics so that you know how to do all the rest of these things. The reason why I think it's important for everyone to know data types is because you might have experienced that you see a definition of a function and it says something like that you need a set and a numeric expression, or you might have gotten an error and you're not sure what it means, that it must not be a set, or you want to write or understand more complex MDX queries, and this is where also the knowledge of data types would help you. First, let's start with the data types, and the first one I want to talk about is hierarchy. Right now, in flex.bi, there is one place where hierarchies are used, and it's the time dimension, but in future, we are going to implement them in more dimensions. This is, in future, we'll have also item types for items, so it's not going to be items for every group, it's going to be items under every type. To demonstrate you how this looks, I'm going to also demonstrate in flex.bi how most of these things look or work, and for that I will want to choose the time dimension to show the hierarchies. So I'm going to use non-empty so that we don't have empty fields, and there is a section all hierarchy level members, and we can see here that there's no name for this hierarchy, it's the default hierarchy, then there's weekly hierarchy, and there's fiscal hierarchy available. So let's say if I pick a day for this hierarchy and I bookmark it, then I choose the weekly hierarchy, I book the same member, and also will do the same for the fiscal hierarchy. So I have all three of them bookmarked here, and if I try to create a new member, then it's going to be, I'm going to select all of them, and as you can see, they're all different. And the reason is because they're in hierarchies. So this starts with the quarter, month, and then day. Weekly hierarchy goes up. It also starts with the year. So the weekly hierarchy goes year, week, and then day, and the fiscal hierarchy goes starts with a different quarter. So this is different. And the place where hierarchy is defined is here. The first brackets is what hierarchy we want to use for the dimension. Next is dimension level expressions, and these expressions tell you what level you want to use in every hierarchy. Okay, what levels you want to use, and it's very similar. You can see here, select all members at level. So these are levels already, and you can find them also if you try to define a new calculated member. hierarchy levels. Weekly hierarchy, you just select year, or quarter, or month, or day. So this part of the MDX is the hierarchy level. And the hierarchy levels can be used in functions like descendants here. And as you can see, you need a level to define a level for this function. So you would have to pick one of these to make the function work. Then let's move on to some more specific and basic expressions, and the most basic one is a member expression. Here we can see there's one member selected, and we can see that it's from customer's dimension, and it's just one customer. And with member expressions, you can get different information from member expression, and you can do or combine the member expression with different other expressions. So you can see here I can get different measures like item base amount or item quantity for this customer. And this customer also has different properties that are all available for me, like customer city, telephone, email. They have some dates in there and customer classifications. And I also can combine the member with other dimensions or other members to get different measures. So this is not the item based amount just for the customer. It's also for the item group audio and the person Samuel Jackson. So these are their values. Let's try to select one member in flex.bi. Let's use the customer dimension, and we can select a member by bookmarking it. When we bookmark it, let's try to define a new member. Let's try to define a new member, and you can see it's bookmarked. I select this, and so this will be the member. If I create it, now I'm going to select the bookmarked one and this new one. As you can see, they are the same. So I just got a member. And for members, there is a function that I showed you before that they have properties, the members, and there's a function to see all the properties for one member. And that's customer dimension hierarchy and properties. So for this customer, we can see these are all the available properties, and you can use it for any dimension to see what kind of properties does the dimension or the member have. Okay. From like we combined here the member with different other dimensions. In a similar way, tuples are created. So this is one tuple, and what it is, it's a combination of two members. And I have selected the customer dimension and the invoice dimension. So this is the combination or the common item base amount and common quantity for this customer and this invoice. And as before, you can get properties from the customers, but also you can get properties from the invoice and also combine them with different dimensions. Let's try to create one in flex.bi. So I'm gonna bookmark something here. Then I'm going to search a bookmark for CD player, bookmark here. And what I'm trying to do now is I'm trying to get the syntax of how to write how to point out how to write the members. So I'm going to copy this and let's create a new member. So this is the item CD player, and I put and then it's the customer. And what defines a tuple is these brackets. So if I put them in these brackets, it means it's a tuple. So now I have, we cannot see the tuple here, but this item base amount is the combination of the two of them. Let's remove this one. So this is a tuple. I could also do the same thing by taking the customer and item dimension together, selecting this, and it would show, let's remove this, and it, as you can see, it shows this same item base amount. Then there are sets, and sets are a list of members or tuples. When I started using flex.bi, this is one of the errors I was confused about. It said that, I showed it in the second slide, the function cannot return a set, basically. And I also got this error, and I was really confused. And this is, I think, is one of the most common ones. And the reason why it throws an error like this is because a set is a list of members, so flex.bi does not know what you want to do with all of them. And you're returning more than one value, and so it's like, hey, what do I do with this? Let's say a set would be if I select all members at the customer level. So this is a set, and I can define it in calculated members, in a calculated member in a different way. By selecting the customer level, and then I think the function is here. I can use members. So this will return the same thing I did visually. So if I press create, it's going to throw an error that I cannot return a set. As you can see here. What I can do is use one of the aggregator functions to deal with this set. For example, I can use count, and as you can see, this is the function. It wants a set. So if I copy this in, then it's going to count how many members are in this set. So this is one of the things we can do with a set. So we have 59 customers. We can also aggregate the customers, we can sum them, there was an average function, and so on. So there are multiple things you can do with sets. And a set of tuples is also a set. One way of writing a tuple set is with a function non-empty cross join. Here I've took all the customer members and all the items from item dimension, and then I put them together in tuples in a similar way, and this function will return all of the customers that have this item, any value for this item. So it's basically the same if I would do this. I'll select all customers, I will select all items, and I will press non-empty. So this would be the result of that function. Okay. So set of tuples. Moving on, the next expression is a very basic one, and it's numeric expression. And numeric expression means a number or some kind of decimal number, regular number, some kind of value that the flex.bi wants to return. And these are basically measures. For the most cases, these are going to be measures. So if you use all of them, flex.bi will turn them into numeric expressions. Turn anything. If we combine a customer with the item amount, it's going to turn it into a value. But and other examples of numeric expression are, like I said, numbers. So this is the essence of a numeric expression. It wants to be a number. It has to be a number. And like I said before, any measures would turn members, tuples, or sets into numbers. And there are also different functions that return numeric expressions, like sum or count that we used before. So count will return a number. That was 59 before. So that will be a numeric expression. Strings, this is the next type, string, and string is a sequence of characters. And what makes a text or a sequence of characters a string is the quotation marks. So if we write anything and then put it in quotation marks, flex.bi is going to know that it's a string. For example, if I write test string, and if I write string 1, 2, 3, and I will try to create this, then I will get an error. So it's trying to know what dimension I'm using or so on. But if I put the quotation marks here, and then I create, now it's a string. If I select it, it's going to return what I've written there. And you can see here there are different, anything you put between these quotation marks is going to turn into a string. It can be address, or it can be, you can write dates, and they will be strings. So date and datetime members are very connected to strings, and they are in some ways the same. Because all of these are potentially date or datetime members. The difference between a regular string and a date or datetime member is where it is used. So if we use these in, for example, if there's a function date without time, and this function takes date as a parameter. So I will use a trick now to rename this function, and this function like this doesn't exist with 2 A's, so I'm going to try to create this, and I'm going to get an error. And the error is going to say that I want to use string. But if I do the correct name, it is going to try to convert this string into a date. Date 1, as you can see, this is a date now. And it turned into date because it was used in a function which tries to do that. There are different ways how to write string expressions or strings. Here are a couple of examples, and you can find more by clicking here on in the documentation page. Here are a couple of more examples how to write these strings. And to get even more examples, you can go to this website. And there are going to be even more examples how to do that. For example, I have another example where I've tried it today. And if I activate the calculator member, you can see that it's today's date. So it works with different kind of strings. Another type that is used in flex.bi is a logical, or some places it's called condition. And it's logical can return only true or false. So it's a true-false statement. Here are a couple of examples. I have one example here, just two measures that are going to be turned into numeric expressions. They're compared, which one is bigger. I have, if I run this query, you can see it's all true. Now I have another one here, and the special thing about this one is that it's a function. And in the function description, it's written that it's going to return a logical expression. And this can be used in other functions as well, but to demonstrate how this works, it was checking the invoice balance. So I'm going to select invoice balance and see that it's false, because the invoice balance is not empty for this customer, but for this customer, the invoice balance is empty, so that's why it returns true. So logical is a true-false statement. For logical expressions, there's also two extra words that you can use, and it's and or. And for example, if for an and to work, if I write this and then I can select one equals one, let's say not equals one, it's the same. Then for this logical expression to be true, this has to be true and this has to be true. If I put or, then only one of them has to be true, and if one of them is true, then it's going to return a true together. If one of them is false, it's going to return false together. So this is how you combine multiple logicals. So we just went through all of the data types. And just to remind you what these were, then hierarchy was the weekly, fiscal, or regular hierarchy. That is the first bracket. The next one is dimension level, where we tell flex.bi what level of dimension we are going to use. For example, customers, we have categories and customers. Which one do we want to use? A member expression is just one member. A tuple is combination of two members. Set is a list of members. Numeric expression is numbers. Strings is sequence of characters. Date time is a date time member. A string that is turned into a date time or date. And then there's logical expression, what is true, just true or false. So we covered these, and now let's talk about how case statements work. I am not sure if you have ever used them, but I have found in some cases that it's very useful. And this is the structure of how case statements work. So I have colored with red the statements that are going to always have to be used. So a case statement always starts with a case, it always ends with an end, and then there's at least one when, then statement. And for the when statement, in order for it to work, you have to return a logical expression. So it has to know if it's true or false. And if this is true, then it does this line, then it will do the true. If this fails and the logical returns false, then you can add another statement. And it follows the same way. If it's true, then it's going to do the then thing. It's going to do this thing. And the same thing, and to finish up, you can once in the case statement, you can use else statement. And what this will do, that this will run in any case. So if everything behind the else is false and nothing has happened, then the flex.bi will do the else statement. I have prepared a case statement here. I'm going to turn off the other ones for now. Okay, good. So this is how it looks. And this is the MDX. So what I did is I checked if what this does, it checks for the customer if its item-based amount is below 60,000. So if this is true, if this statement goes true, it's going to return a string small. If this is not true, then the flex.bi will move on and check the second logical. That is the item-based amount smaller than 80,000? So if this is true, it is going to return normal. And in any case, and if these both of those are not true, then it's going to return big. So let's check how it works. You can see here, this is below 60,000, so it returns small. So this is below 60,000, or this is below 80,000, but it's above 60,000, so it returns normal. This is below 60, this is below 80, and we have 87, which is a big one, and 88, another big one. And I just want to remind you that if it's for some statements like below, for 53, for example, both of these will be true because it's below 60 and it's below 80. But since this one came true first, flex.bi did not, the query did not even try to look what's further, and it just returned this and it ended. So it's like, oh, this is true, small, and that's it, I'm done with this case statement. It did not even try to look here. That's why it's only small. So I see we have a question. If logical statement fits two when statements, then the first then is it so? Okay, yeah. This is exactly. Thank you for the question, Zane. I guess this is what I just covered. That, and I'm going to repeat that. That if the first one is true, then it's going to just do the first one and not even try to check the other ones. And the case, this is one of the examples that I have. One examples how a case can be used, and I have also used I have two other ways that I have used the case statement as well. So one is for dividing by 0. It might happen that you did some query where you have division and divisor is 0. In these cases, flex.bi returns infinity because you cannot divide by 0. So I have a calculator member here that does just that. So it checks case when this is bigger than 0, or you might do like this. It is not equal 0. This would mean it is not equal 0, because it might be, I guess, below 0 as well. Then, and only then, we do this query. So if this will not come true, it will not return anything, because there is no else statement, or there is no other when statement that can come true. So it will return anything if this item base amount previous period would not be 0. And this is how we will avoid the infinity. Another case I have used this is in a 12-month projection report. And at the start of the report, this is the trend. And the trend is created from this data, and it creates a line of how the item base amount is going over the months, like the average. And what I wanted to also do, I wanted to continue the line, but I needed a different calculator member for that, and I used case statement for that. So if I check the table, you can see here that the trend goes only so far, and then the projection starts. And projection starts here as well. So if I check the calculated members, you can see here if the rank is bigger than 0, then it does the trend. And in other cases, when the rank matches or is smaller than 0, or it does not match 0, if it matches 0, then it does the projection. This is another way how to use it. So I'm going to move on from the case statements now to the MDX, the structure of MDX functions. The main thing to remember for MDX functions is that they take specific values and they return specific types and values. If I try to define a new member, there's a section below here. We have some couple of aggregator functions and other ones. And if I click on some, for example, you can see that these are the expressions or members that they take. And this sum function takes a set and a numeric expression, though the numeric expression is optional. And the other functions like the sentence, it takes a member and it takes a level, and so on. And this function returns, I know that this function returns a numeric expression, and this one returns a set. And you can find that in, let's try different. You can find that in the documentation, MDX function reference, and you can see returns the date, returns the hierarchy, returns if date. So it's written here what it also returns. So in this way, you can combine these functions. If you know what kind of parameters does it take, so if it takes, let's go back here. So descendants. Returns the set. So descendants returns a set. So that means that if I can have a count function that takes a set, I know that I can use this one in the count. And this is going to work because this returns set and count takes a set. So I can combine these by knowing what kind of types that they use. Functions used writing MDX. In writing MDX, there are 3 different brackets that are used. The first one are just parentheses, and these are used for opening or closing functions. So if I click on the parenthesis, I can see where it starts and where it ends. It's the second, and the same for the other one. The square brackets are used to define levels and hierarchies. If I go back, oh, okay, this dimension does not have hierarchies. I'm gonna go customers and select again the category. You can see in these brackets is defined the hierarchy and the level. And the last type of brackets is curly brackets. I've created the one calculate the member here, and curly brackets are used to create sets. Sort of what I did here. What I'll do again, I guess. I bookmarked. Let's try to bookmark 1, 2, and let's put this one. Bookmark 3 members. And I can use them to, with these kind of brackets, to create a set. I select the first one, I put a comma. I can select another one, put a comma, the third one, and it's going to create a, okay, it shows me that the name is already taken, so we're just gonna do set that. And so if I do this, it's going to return an error that it must not be a set. We know what is a set now, and here are some aggregator functions. So let's count how many of the members we have there. As you can see, it's 3. It's kind of confusing because it's item base mode select here, but it's 3 members. Okay, and there's a, the functions can also be written with a dot. You might have seen me use it today, for example, as functions as like current member or previous member. Let's do, okay, let's select all the customers and let's try using the, if I do customer hierarchy, customer level, and I do current member, or I can select the same current member here, and I do a cool function called name. So this function will work on this level, and this function name will work on this hierarchy, this level, and on the thing what this function returns, current member. And the current member returns the current member. So this function works on a member. So if I create it, and so this will return the name of the current member that is selected in the row. So this is the other type of function using a dot. And now I am going to show you how I break down problems. And the reason I think this is useful because when I was starting off, I also did not know what to do if my function did not work, or if it didn't give the correct result, and also if it threw errors, so that errors that I did not understand. So I'm going to take a complicated calculated member, and it is going to be wrong. I'm going to show you right now. We don't need this. I have prepared one, and it's called oldest unpaid invoice. And as you can see, it does not return anything. But if I go to the original oldest unpaid invoice date member, then you can see it returns a date. So I modified it a little bit so to show you how I would find what's wrong with it. So this is how the member would look like, and I will just explain in just a minute how it works altogether. What I'm going to do is I'm going to use a technique where I break it down into some smaller problems to find out where it's not working, and I will try to compare it with a report. I'm going to try to recreate the same thing in a report, and I'm going to use a very useful function for that. That's called set to string. And I just show you the function dot name, and just put it there so you know that it's also useful in these cases. So what is happening here? What we learned before, that functions start with brackets and they end with brackets. So if I click here, I know this function ends here. So okay, I see this is one function here. Then this function probably has some kind of parameters. And the first one should be filter, because this is where it starts. And the filter function, it ends here. So this should be the first parameter for the order function. Good, I know this is the first one. Now, this is a hierarchy, and we get the invoice date from that. So, and there's a comma. So, okay, this must be the second one, and this must be the third one. So this order function has three parameters, this one, and this one. Next, we have filter function, and filter function ends here, and the first parameter looks like it's the non-empty cross join. This one ends here, we have comma. Okay, this is the first parameter, and then there's this one followed by and. So, okay, we know what's and and is a logical expression. So this is going to be logical, and this is the combination of two logicals. Good, so filter function has this first parameter, and then it has a combination of two logicals. So far, so good. Okay, now let's start with the first thing. It's not the order, it's not the function filter, but it's going to be non-empty cross join. So let's check to see if how this works, if this returns what I want it to return. For that, I'm going to open a new tab, and I'm going to show you what this function does. So It's like I explained you before, and I'm going to show you again what it does. It does a non-empty cross joint between a member from a customer dimension. I want to select this member, and between all invoices in invoice level. So this invoice level, all the members from this level. Okay, so I know where it is. That means that I want to select this level and all of the invoices. I'm gonna do, and it's non-empty, and you can see there's non-empty. So this is non-empty cross join. Put a measure, then I don't need all the customers, I just wanted this one. So this is what it should return. For this customer, all of its invoices that have any item base amount or any value. So I'm going to take this, out. Okay, I'm going to do another tab window. Let's recreate this. I'm going to bookmark the same customer, the same one customer, remove this, and then I will define a new member here. And I'm going to use this in the member because I want to see if this part of the MDX query works correctly. Test MDX, and like I showed you in the slide, I'm going to use the set to string function. So set to string, this is where it starts, and this is going to be where it ends. I'm gonna run it, and there's a lot of text, but I'm gonna explain what happened. So as we see in the report that I recreated, it made tuples from this customer and all of its invoices. So this bracket, as we know, it's a set. So it means that, okay, we will have a set here. There's an opening bracket here, and it ends here. So there's a comma, so this is a tuple. This is exactly what I recreated here. And let's check this. This is the invoice number from the invoice. So if I check it right here, then okay, that's the first one. Then this is an invoice, and okay, this is another invoice. I try to find it in the finder here, and we can see the other invoices here as well. So I would say that this probably is correct. So we got the tuples that we wanted. So now the next one, what we have is if the logical invoice base balance is bigger than 0. So for this logical, we also will need the filter function. So let's test if this works. We're going to use the same set to string because filter also, filter, if we check filter function here, it takes a set and a condition, and it's not written here, but okay, I can check it. Filter, and it returns the set. So it's going to return a set. So I still want to make the set to a string. And now let's see what this returns. In the meantime, I'm going to recreate the same in the report. So I don't need the item base amount. Instead, I need the invoice balance. So, okay, so it returned non-empty and all of the invoices that have some kind of invoice balance. So we have a set here, it's smaller, and it's a, like here set, we have not tuple, so it returns tuples. That's great. I'm going to take the check. This is the invoice, so I'm going to copy the invoice number into here and look for it in this report. So okay, it's the first one. That's good. If I check the second invoice number, then yeah, it returns also the second one. Maybe we can check the third one. Yes, so it looks like all of the invoices are here. So far it's working good. Next, in this MDX, I'm trying to return only those invoices that have the date where today is over the due date for the invoice. So if we are late to pay for the invoice, I want only those ones, because some invoices might have base balance, but we have still time to pay for the invoice. But I want those that are late for the payment. That's why I use the date compare function, and it returns 1 if the invoice that today, what is now, is over the invoice due date. If you want to find out more, you can check it out in the documentation. But I'm going to move on here, and I will add it as an and I want this. Now, if I update this member, I also want to do it in this report. So I want to see invoice properties, and I want to see if I want to see the invoice due date. Okay, great. But as you can see, now we have all the empty invoices as well, because we are returning something here. So I'm going to use a little trick. I will use filter matches, and since this filtering uses regular expressions, I can put a dot, and it will return only those invoice balances that have anything in them, basically if they're not empty. I'm not going to explain you how the regular expressions work for now, but if you want to do that, you can check this link. So now we have invoice balances and their due date in this report. And if we check the MDX, this is exactly what we wanted to get. And so this should be the set that has only invoices that are over due date. So far, it's working correctly. Now, it returned. So I can also use this as, I don't know, an extra, and now I can filter rows that matches true. So I will get now all of the invoices that we are over the due date now. And so this works. And next thing that I do in the MDX is that I want to sort them, because I want to know which one is the oldest of the invoices. In order to do that, I use a function order. And let's copy this function. It still returns a string, so I'm going to copy in, and it's going to sort by the invoice date. So if I update this, so this one, I'm going to do the same thing here. July 25th, so this 620, I need the other way around. So 373, okay, yes, 373, this is the first invoice, the latest date, and this is exactly when I wanted to. Let's check the second one is this one, and the second result. So this is sorted correctly. Now, what I do in the MDX query next is I return the first item from the set, because so far we are getting a set of customer invoices that have invoice balance and they are over due date. But I want to get only one that is the oldest one. So for that, I can use item function. So it would return the first one. So let's copy this in to the MDX, like so. This is how it will look. I will do the same order, but after the order is ended, I will not return the full set, but I will return the first item. So if I update this, then it should return the first item. Oh, wait a second. It's not returning the first item, the 373, but it's returning the second one. So now I can start wondering, hey, something is wrong, like I was wondering before. I can figure out that this item function is not working. And now I know that, since I know that the item function is not working, I can look for solutions on this exact place. I know where the problem is, so I can solve it. And the reason why it's returning the second invoice is because the counting starts actually from 0, right? Maybe you have done some programming, you would know also that if the counting starts actually from 0, not 1. So the 0th item would be actually the first one, right? And if I never try to debug this and try to find the problem, I might never have to remember this. So now, if I check the invoice, I know, oh, it's the first one, this is the correct one. So I'm also going to use it in the other item here. And let's copy it all again. And let's try to get the name. I want to see which invoice is it. Maybe the date matches, maybe the date matches, but the invoice is a different one. So let's try to get the name of the invoice. Now, since we are not returning a set anymore, the set to string function does not know what to do. So we're gonna remove it. And now we will get the string of the invoice that we got from all of this calculation. And as you can see, the 373 invoice, exactly the one that we wanted. Now I can finish this member and know that, okay, it's going to get the invoice date for it. And if I update it, then I see, oh, now I get the invoice dates, and the 21st of April, oh, May. Against all trading. So it's due date. Okay. So I return the invoice date instead of the due date. So that's why if I select now a property invoice date, it will return that is the 21st of April. And that's exactly what it returns here. So now it's correct, and I have fixed the error or the mistake that I did not know about. Whew, that was hard for me as well. I'm really tired, and so let's try to finish this up with some little things. And one is comments. And sometimes I use comments if I want to change a calculated member. I did 2 Windowses because of testing purposes. And sometimes what I do is if I don't know if I want to change the calculated member, I copy it and I put it in the comments, like so. And now the flex.bi does not try to see this or calculate any of this. And now I can change this one, how I want to do. And if this does not work, I can return back to the previous version. So this is one way how I'm using this. Another way how to use this is to write comments on what did you want to return there or why you changed something. So comments are useful in these ways, and maybe you have some custom way you want to use comments. So if you write anything between those symbols, flex.bi will think it's a comment, it's not for calculating, and it will also work with 2 of these symbols, like so. If I put these symbols here, now it's a comment. And if I put it in the middle, then the rest of the line is a comment and nothing else. This is how comments work. And here's a link to documentation about comments, how they're used as well. There is another way how to use comments, and it's with making groups. If you go now to the templates account where I have that I'm using right now, you can see that there are different groups like sample, training report, target monitoring, team competitions, trends and forecastings, and so on. And the way I did that is by adding this comment. You have to type annotations, group, and the group name. So this is the way flex.bi is going to. So this is unpaid invoices. If I go below, you can see here it's an unpaid invoice. Actually, this is one of the examples. I have left an old MDX that I tried out here below the original one, and this is, you can see what I have tried out before. And I left it there because I did not know if this is truly going to work. Let's expand this. I did not know if this is really going to work, so I might have wanted to return to the older version, so I commented that out. And I also have I used the comment here, and it's a group for the webinar, if you did notice maybe. And another feature you can use is formatting. And if I select this wrong member and I would have, oh no, sorry, I want to this, and I want to this, and then I would, if I had default formatting and I would try to update this now, then and I would also turn it on, you will see a number, but we return a date. So this is one of the ways how the dates are actually stored in flex.bi. It's a number, but if we specify flex.bi that we want to see it as a date, like so, then it's going to turn it into a normal date. So there are other formatting ways like percentages. You want to see decimal instead just an integer, or you want to see minutes and so on. So this is another feature you can use.